Dealing with discontinuities in dy dx. At the point where dy dx fails to exist, dx dy might exist. To find the arc length, we can express the function in terms of y. And so if y equals f of x, we can express x as g of y. If y is f of x, then dy dx is f prime of x, assuming that the derivative exists. If the derivative doesn't exist, and we can rewrite the function in terms of y, x equals g of y, therefore dx dy is g prime of y. For example, find the length of the curve y equals x over 2 to the power 2/3 from x equals 0 to x equals 2. If we were to integrate along the x-axis, we would have to find y prime or f prime of x. Y prime is 2/3 x over 2 to the minus 1/3 power using the chain rule multiplied 1/2. This can be simplified to 1/3 2 over x to the power positive 1/3. But this is undefined when x equals 0, so we cannot use the arc length formulas, the square root of 1 plus f prime of x squared dx. Instead, we're going to rewrite the function in terms of y. Y equals x over 2 to the power 2/3. Isolate x, raised to the 3/2 both sides of the equation. We obtain x equal to y 3/2. Then dx with respect to y, dx dy, is 2 times 3/2 times y to the 1/2, which simplifies to 3 square root of y. This derivative is defined on the corresponding interval y equals 0 to y equals 1. Using the arc length formulas in terms of y, the length L equals the integral from y equals c to y equals d, the square root of 1 plus dx dy squared dy, but dx dy is 3 square root of y. Simplifies the integrand. We have the integral from c to d, the square root of 1 plus 9y dy. When x equals 0, y equals x over 2 to the 2/3 power, which is 0 over 2 2/3, which is 0. When x equals 2, y equals the quantity 2 over 2 2/3, which is 1. And so the lower limit of integration c is 0, and the upper limit of integration d is 1. The definite integral along the x-axis would have been 0 to 2, but along the y-axis, it is from 0 to 1, as shown in the graph. And so the arc length is the definite integral from y equals 0 to y equals 1, the square root of 1 plus 9y dy. We can either use substitution to evaluate the definite integral, or we can just simply guess and check. The square root of 1 plus 9y is the same as 1 plus 9y to the 1/2 power. The antiderivative of 1 plus 9y to the 1/2 is 1 plus 9y to the 3/2 times 2/3 divided by 9. Evaluate this antiderivative at y equals 0 and y equals 1. We first simplify the antiderivative. It is 2 over 27, the square root of 1 plus 9y cubed. Evaluate this at y equals 0 and y equals 1. Plug in 1, we have 1 plus 9 times 1 cubed. And then plug in 0, we have 1 plus 9 times 0 cubed. And so this is 2 over 27, 10 root 10 minus 1. And this is the exact length of the curve y equals x over 2 to the 2/3 power from x equal to 0 to x equal to 2.